Hi everyone, the purpose of this video is to introduce spectrophotometry, which is an important lab technique we use a lot in this class. Here's the spectrophotometer apparatus we'll use. Here's a serial dilution of a compound which is blue in aqueous solution. The first one here is 1 molar, then 2, and 3 molar, 4 molar, and 5 molar. So I wonder what the concentration of this sample is. You may remember using a colorimeter in the fall, and we reasoned about the fact that I'm going to use a 635 nanometer wavelength red light in order to analyze this blue solution. Now you can see there's a linear relationship starting to form. Now we'll be looking at this relationship and analyzing the concentration of aspirin in a tablet. I'm going to dye the aspirin using iron 3 chloride. There's what iron 3 chloride looks like, and our first task in this lab is to prepare 250 mils of a 0.04 molar solution of iron 3 chloride. This is a good time to quickly review how we should prepare a solution from a solid. So that narrow neck of the flask is what allows you to measure that final volume precisely. Next, in step 3, we want to prepare this tablet. So I'm going to mix it just by transferring it to a different cylinder. And now it's effectively mixed. I'm going to go ahead and put that into a pipette. We really only need a tiny sample in order to measure the absorbance. So this is solution A. Now I'm going to go ahead and make solutions B through E. Solution A had a low absorbance. Solution B, an even higher absorbance. And it makes sense because solutions C and D and E are ever more concentrated, and as they're more concentrated, they are darker, and so more light is absorbed. It looks like a linear relationship. We're going to want to refer back to these numbers later in our lab in order to calculate the concentration of our unknown. A separate video will talk about the data analysis and how we can find out exactly how much active ingredient is in the aspirin.